Hey there, my kiddos. I'm making this video so that we can have some information about solving multiple angle problems. Okay, so what you see here, hopefully what you see is this is why they're called multiple angles, because we have a variable in front of your, we have a coefficient in front of your variable. Usually it was sine of theta or secant of theta, right? Just a single variable. Well, now we have a 2 in front of your variable. Okay, so we really have to focus on our steps when we're trying to solve these to get rid of the trig word like we were doing a couple weeks ago, but I said it doesn't make that big of a difference last time. But now it's going to make a pretty big difference. So we start, of course, by always doing our simple math first to get everything away from the trig value. But now notice the x is here in parentheses. Okay, so we can't just divide by 2 because you can't ever just do anything out of parentheses. Once again, we have to get rid of the secant. Okay, we have to get rid of secant because then once we get rid of secant, now the parentheses will go away on their own. And we get rid of the trig by doing the inverse of both sides. Okay, that's how we get rid of the trig part of our equation, okay, which leaves us with the 2x on the inside. Okay, so we're looking for all the angles where the secant has a value of -2. Okay, so looking at our unit circle, the first place where the secant has a value of -2 is where the cosine is -1/2, which is 2 pi over 3. Okay, and there's another place, right? So now we have two equations because there's two places on the unit circle where the secant value is -2, and that's at 4 pi over 3 also. Okay, so here's where it's important to understand that we have two answers on your unit circle where the secant is -2. So we make two equations. We set your angle, right? This is where your angle is equal to the first angle where secant is -2. And then we set your variable angle equal to the second angle where it is -2. Okay, so now we're going to solve by dividing by 2. I never like to divide a fraction by 2. I always multiply it by 1/2 because that is what we're doing, right? Multiplying by 1/2, dividing by 2, those are the same things. And when we have a fraction, hopefully we can see that it's easy to divide, right? 2 divided by 2 reduces our fraction straight away. I don't have to worry about reciprocating and all that other stuff that goes on. So one of my answers looks like 1 pi over 3. Okay, so pi over 3 is one of my answers. And the other one, 4 and 2 can reduce. So x is 2 pi over 3. Okay, so these are the two angles that if I start there, if I start at pi over 3, and I multiply that angle by 2, right? I'm starting at pi over 3, multiply that angle by 2, take the secant of that angle, and then add 2 to it, I'm going to get an answer of 0. Okay. Also, if I start at 2 pi over 3, that's my angle, 2 pi over 3 is right here, and I multiply that by 2, 2 times 2 pi over 3, and then take the secant of that and then add 2, I will get 0 as my answer. Okay, so it has to work out when we do our PEMDAS, right, when we do our plugging back in. So once again, we do simple math first. Okay, we do our simple stuff first. So negative cotan squared 2x equals, nope, not 0, equals -1. So divide by -1 to get rid of the negative, right? We don't want to have a negative out there. So cotan squared of 2x equals +1. So now I'm taking the square root of both sides. And all that does is get rid of my square. That does not get rid of my cotan. That just gets rid of the square. So now I have positive and -1, because when I take the square root of something, I get two separate values. So now we need to get rid of cotan by taking the inverse, the inverse cotan of these angles. Okay, so let's see. Where are all the angles where the cotan is positive and negative 1? Okay, so we need to put an equation for every single one of them. So we have 2x equals, the first place is pi over 4. The second place is 3 pi over 4. Okay, that's where cotan is negative. The third place is 5 pi over 4. That's where cotan is back to being positive. Sorry, not 3x, but 2x. And then 2x equals 7 pi over 4. Okay, 7 pi over 4. So now we're going to solve all 4 of these because there are 4 places on your unit circle where the cotan is negative and positive 1. So divide everything by 2, right? Multiply by 1/2. Divide by 2 with the number, multiply by 1/2 with the fraction. Divide by 2 with the number, multiply by 1/2 with the fraction. Okay, so we do top times top, bottom times bottom. Half of pi over 4 is pi over 8. Half of 3 pi over 4 is 3 pi over 8. Half of 5 pi over 4 is 5 pi over 8. Half of 7 pi over 4 is 7 pi over 8. Remember, when we're doing fractional multiplication, we do the denominators times the denominators, right? So 4 times 2 is always going to be 8. And then we're multiplying the numerator by 1, so that doesn't change the numerator at all. Okay? So divide the number, but multiply your fraction by 1/2. If you're dividing by 2, that means you're multiplying by 1/2. If you're dividing by 3, that means you're multiplying by 1/3. Okay, so multiply the fraction, multiply your angle by the fraction, but divide by the number. Okay, you'll get the hang of it. Okay, so here we have the one that we need to factor, right? This is now a factorable trig quadratic. It's going to factor like 2x squared plus x minus 1, right? So we're going to change it to a quadratic so that we can factor this easier. This is 2x minus 1 and x plus 1, right? Because we want the middle number to be positive, so we have to have a positive 2 and a negative 1 when we FOIL this back out. So our factors of 2 cosine squared is going to be 2 cosine, right, x over 2 minus 1, and 2 cosine x over 2 plus, no, not 2, sorry, there's not a 2 here. There's only a 2 in one of your factors. So there we go. There's my brain. Equals 0. So the rule is you take each of your factors, 2 cosine x over 2 minus 1, set it equal to 0, and take cosine x over 2 plus 1, set it equal to 0. Okay, so when we factor your trig quadratic, take each of your, each of your factors and set them equal to 0. So we're going to add 1 to both sides here and then divide by 2. Yes, I'm doing this quickly. Cosine of x over 2 equals positive 1/2. Okay, and then minus 1 from both sides. Cosine of x over 2 equals negative 1. So we get rid of the cosine by taking the inverse cosine. Right? This is how we get rid of our trig. We take the inverse cosine of both sides. So we are looking for all the angles where the cosine has a value of positive 1/2. And we're also looking for all the angles where the cosine has a value of negative 1. Okay, so hopefully you know there's 2 places where the cosine is 1/2. Okay, the first place where the cosine is 1/2 is pi over 6. The second place where the cosine is 1/2 is, there it is, Sorry, not pi over 6. That was where the sign is. Oh, my brain this morning, let's erase this, not pi over 6. Pi over 3, thank you for catching that. Pi over 3 is a place where the cosine is 1/2, and 5 pi over 3. That's where the cosine is 1/2. Man, what is going on? 5 pi over 3. And then over here, the cosine is -1 at pi. I know that one. The cosine is -1 at pi. So we're going to have 3 answers. So let's solve. We're going to multiply both sides by 2. That's how we get rid of a fraction, is by multiplying by 2. Okay, we multiply both sides by 2. And over here, we're going to multiply both sides by 2, right, to get rid of that denominator. So let's see what happens. When I multiply a fraction times a number, right, I just multiply on the top. So this becomes 2 pi over 3. The next one becomes 5 times 2 is 10 pi over 3. And then this one here in red is just 2 pi. Okay, now this one here is suspicious. If we're just solving from 0 to 2 pi, if that is our domain, we can only solve from 0 to 2 pi. 10 pi over 3 doesn't fall within that range. Okay, hopefully you know that 2 pi is 6 pi over 3, right? That's, as a fraction, 2 pi becomes 6 pi over 3. Well, 10 is more than 6. So 10 pi over 3 is going around your unit circle more than once to get to the answer, which means that 10 pi over 3, even though it was an answer to my problem, is not a solution because it's not within my domain of 0 to 2 pi. So I only have 2 angles that are my answers. Okay, the first one is 2 pi over 3, and the second one is 2 pi, because 10 pi over 3 is too big. It's not within my domain. So that's something we got to look at the end of your problems. Is your answer actually a solution? Is it within the 0 to 2 pi realm? Okay, so take the inverse, right, this part, and split it into your 2 angles, or potentially your 4 angles where it's equal to that value. Okay, and that's how we solve these multiple angle problems. Okay, we'll see you in class.